Okay, so we're going to be looking at similar figures, and we're going to look at that first because that's going to help us with our dimensional changes that we're going to have with our different dimensions in 1 dimension, 2 dimension, and 3 dimension, and with some of our measurements. So figures are called similar when their corresponding sides are all in proportion and their corresponding angles are congruent. So we're going to be using proportions to solve for the missing sides of the similar figures. So I'm going to pull this up so we can see our whole page. And I did example 1 and 2 here, so I will demonstrate that. First thing you want to do is you want to find your scale factor, because the scale factor is going to help us with our dimensional changes. So in order to do that, I have to compare two of the corresponding sides that are given. So if I look at the left side here, I have the number 4, and if I look at the left side here, I have the number 8. So that's where I'm going to base my scale factor on because those numbers were given to me. If I look at the bottom, I have a number and a variable. I can't establish a scale factor from that. And if I look at my hypotenuse, 4 square root of 2, and y, I also have a number and a variable, and I can't establish a scale factor from that. So I'm going to compare 4 to 8, and I'm going to simplify that down because the scale factor should be the simplest form of a fraction, and that's going to be 1 over 2. That's going to be my scale factor, and that's going to be the basis for our dimensional changes. So now I need to find the other two sides of my triangle, and I'm going to use the scale factor and a proportion to solve for it. So I'm going to use 1/2, and then I'm going to find my bottom side. So 1/2 is going to be 4 to x because I started with my left side first and then went to my right side. And to solve a proportion, we use cross multiplication. So I'm going to cross multiply 1 and x, and I get x equals. And I'm going to cross multiply 4 times 2, and I get 8. So my missing side on the bottom here is 8. Now I'm going to set up another proportion using my scale factor, 1/2. And I'm going to set it up using my hypotenuse. Those are the corresponding sides. So that's going to be 4 square root of 2 over y. And just like the other example, I'm going to cross multiply. So I get y equals, and I'm going to cross multiply. 2 times 4 square root of 2 is 8 square root of 2. And I have those two missing sides. Now I'm going to stop at this point in time because I need to find the missing sides of all of my problems. So now I'm going to move on to number 2. And I'm going to establish the scale factor again. So if I look at my left side, I've got 8 and I've got a. So that doesn't work for me. So if I look at my right side, I've got 8 and 12. That does. I have numbers there. So I'm going to compare 8 to 12. And that's going to simplify down to 2/3. And that's going to be my scale factor. And I'm going to come back to that momentarily. And now I want to find my missing sides. Well, I notice that I have an isosceles triangle here. And the isosceles triangle on the left means that the triangle on the right is also isosceles. So right off the bat, I know A is going to be 12 because it should be isosceles. And you can use your properties to find the missing sides if they warrant it. Otherwise, I am going to have to establish a proportion to find B. And I'm going to use that 2 over 3 ratio. And my B is on the bottom, so I'm going to compare 5 to B because they're both on the bottom. Just like number 1, I'm going to cross multiply to solve, so I get 2B is equal to cross multiply 3 and 5, and I get 15. I'm going to divide by 2, and B is going to equal 7.5. And that's my answer. B is 7.5. Now the other part I need to find is the height. I have my 7.6 here, but I also need to find the height in my other triangle, and I need to set up another proportion. So 2 over 3 using my scale factor is going to equal 7.6 over, and I'm going to use h for height. And just like before, I'm going to cross multiply, so I'm going to have 2h equals 7.6 times 3 is 22.8. I'm going to divide by 2, and my h equals 11.4. Okay, so now I've completed finding all of my missing pieces. So at this point in time is where I allowed the students to find the rest of the problem's missing sides. And I'm going to pause the video for that. Are you awake now? You'll have to excuse my dog for barking. She saw another dog walking down the street. But now you can see I filled in the rest of the missing sides because we really need those missing sides in order to do the dimensional changes. So that's what's coming up next. We're going to do the dimensional changes. Okay, so now we're going to get into the meat of the dimensional changes. We needed the missing sides so we can complete that. So first thing that we're going to look at is we're going to look at the perimeters. And I'm going to find perimeter 1. That'll be this triangle on the left. And that's going to be 4 plus 4 plus 4 square root of 2. That's the exact answer. And estimation-wise, it's going to be 13.66. I don't really like to estimate it here just because the rounding throws things off. And I'm going to find perimeter 2, which is this triangle here that we found. It's 8 square root of 2, and it roughly comes out to 27.31. Okay, so now I want to compare those. I need to compare perimeter 1 to perimeter 2. And I get 13.66 roughly over 27.31. And if you put it in the calculator, it comes out to 0.500 and some odd numbers because it's rounded. But really and truly, it's 0.5. And 0.5 as a fraction is 1/2. Now, why did I want to compare those? Because I needed to check the scale factor of the perimeters. And I wanted to compare it to the scale factor of the original problem. And what you'll notice is that they're exactly the same. That's not a coincidence. This is a one-dimensional measurement. Perimeter is one-dimensional as well as side lengths. And that means the pattern between them is they're equivalent. So whatever the side length scale factor is, the perimeter scale factor will be the same length. Now, I want to repeat this with the area. So I'm going to find the area of the first figure. And since it's a triangle, my area formula is 1/2 base times height. And my base is going to be 4. My height is going to be 4. And my area is going to be 8. And then the area of my second triangle is going to be 1/2. My base is 8. My height is 8. And I get an area of 32. Oops. No, I didn't want to do that. Okay, there we go. Got it back. 32. And I want to compare the areas. I want to compare area 1 to area 2. And that gives me 8 over 32. And that reduces to 1/4. Okay, well, that's not the same as 1/2, but they are related. I can rewrite 1/4 using 1/2. If I take 1/2 and multiply it by another 1/2, then I get the 1/4. Then I can take that 1/2 and I can rewrite it using exponents to the second power. Now, why does that make sense? Area is two-dimensional. I have the base and the height. That means I have to apply that scale factor to the base and the height. So no matter what area I use, I'm going to have to do it twice. And that's the relationship back to 1/2. So I am going to change the ratio back to where it relates to the scale factor of 1/2. And I see that 1/4 is really 1/2 squared in disguise. Okay, let's look at number 2. So again, I want to compare perimeters. So perimeter 1, I'm going to have 8 plus 8 plus 5. That's going to give me 21. Perimeter 2, I'm going to have 12 plus 12 plus 7.5. That's going to give me 31.5. Okay, and I want to compare perimeter 1 to perimeter 2. And that's going to give me 21 over 31.5. Well, guess what? That simplifies down to 2/3. Guess what? That is exactly our scale factor. Perimeter has a pattern of being the same scale factor as our sides. So now let's take a look at the area. You want to take a guess? Let's guess about our area. Well, let's see, what did we learn from the first example? That it's related back to the scale factor. So my scale factor for number 2 is 2/3. And since area is two-dimensional, I can square it to get that two-dimensional one. So 2 squared is 4. 3 squared is 9. So I'm going to guess that the ratio of my areas is 4 to 9. Okay, so let's check. So I'm going to have the area of triangle 1. So it's 1/2 base times height. My base is 5. My height is 7.6. And that gives me an area of 19. Then I'm going to have area 2. So I have 1/2. My base is 7.5. We found that earlier. Times the height, which we found earlier, 11.4. And that gives me an area of 42.75. So I'm going to compare those areas. I'm going to compare 19 to 42.75. And guess what it reduces to? 4/9. So my guess was correct. I just took the scale factor to the second power because area is two-dimensional, and I get a ratio of 4 to 9. So when I took the areas and I compared them, I did get the ratio of 4 to 9. So at this point in time, students need to go ahead and find the perimeter and area of number 3, compare them, and verify that it is consistent with the scale factor. On number 4, you're just going to do the perimeter. You don't have enough information to find that area. On number 5, you're going to do the perimeter and the area. And on number 6, you're going to do the perimeter and the area. And I'm going to pause the video so you can do that. Okay, so now you can see that all of the problems have been worked out. On number 3, the blue is the perimeter and red is the area. And I have worked out the perimeter and area. I have compared the perimeter to the scale factor, and I have compared the areas together and related it back to the scale factor. And you should be able to see that 3/8 shows up in both the perimeter and the area formulas. On number 4, I just did the perimeter. I didn't have enough information to do the area. And the perimeters go back to the scale factor of 4 to 9. On number 5, the perimeters 1/2. And when I compare them, well, not the perimeter, the scale factor is 1/2. When I compare the perimeters, they do reduce down to 1/2, which is equal to the scale factor. And then when I compare the areas, it comes down to 1/4, which is 1/2 squared. And number 6, when I compare the perimeters, I get 30 over 90, which reduces down to 1/3, which is equivalent to the scale factor. And when I compare the areas, I get 30 over 270. That reduces to 1/9, which relates back to 1/3 squared, the same scale factor. So when we're dealing with the dimensions, remember, perimeter is one-dimensional. It's going to be the same as the scale factor. Area is two-dimensional. It's going to be the scale factor squared.